Let's graph the function y equals x plus 1 over 2x plus 3 using transformations. In order to do this, you want to split this up, and the best way to do it is to ignore long division and just use this little trick, which the way you do that is by looking at the coefficient of the highest degree term on the top and the bottom. So the coefficient of x on the bottom is 2. The coefficient of the top is 1. So that's 1/2, basically, 1 over 2. So in other words, if I take 1/2 times 2x plus 3, I get x plus 3 halves. But on the top, I have x plus 1. So what if I take x plus 1, add a half, and then take away 1/2? I did not change the value of this thing. It's still the same. It's still equivalent to the original function. 1/2 minus 1/2 is 0. But I have x plus 1. So let's group it like this. Okay, I have x plus 1 plus 1/2, and then minus 1/2 over 2x plus 3. And then it's x plus 3 halves over 2x plus 3 minus 1/2 over 2x plus 3. If I take the denominator divided by 2, I get exactly the top. So this whole thing is equal to 1/2. And now this 2 is going to multiply the denominator of 2x plus 3. So we have to use transformations to graph this function, which is equivalent to, again, what we started with. Okay. In order to do this, let's factor out a 4 in the denominator. Okay. So let's talk about each one of these. First, the 4 is going to shrink the x by factor of 4. The 3 halves is going to move this to the left 3 halves. The negative is flipping it across the y, and the 1/2 is moving it up by a half. Okay, so the original function that we're going to start with is 1 over x, which looks something like this. One thing to keep in mind is the horizontal asymptote is y equals 0, and the vertical asymptote is x equals 0. So let's see how applying these transformations will change these. Let's look at the x. What's changing the x? Well, we're moving to the left by 3 halves. Is there anything else we're doing as far as shifting? Well, this one we're just shrinking by a factor of 4. We're not actually going to affect the asymptote. So the horizontal asymptote is going to move to, the vertical asymptote is going to move to x equals negative 3 halves. And let's look at the vertical asymptote, the horizontal asymptote. Right now it's at y equals 0. If I flip the sign, if I flip it in the y-axis, 0, if I multiply, in other words, 0 by negative, it's still 0, so that doesn't do anything. And this one moves it up by 1/2. So the horizontal asymptote goes up to 1/2. Okay. Now you want to be careful. First, we want to apply the factor of 4 here. So instead of going to the point 1, 1, now we're going to go to the point 1/4, 1, and then negative 1/4, 1. So something along the lines like this. So this is just y equals 1 over 4x. Now let's use this. Let's shift it over to the left 3 halves. So that's going to move the vertical asymptote. X equals negative 3 halves. Okay. So we applied these two. Now let's flip it across the y. So it's going to go exactly opposite, like this. So this thing in red is negative 1 over 4 times x plus 3 halves. Finally, we're going to add 1 half to this, which means we're going to move the horizontal asymptote to y equals 1 half. The vertical asymptote still remains the same at negative 3 halves. And now this should look something like this. If you want to be more precise, it's good to look at both the x and the y intercepts. And then it's always good to get a point over here. So maybe finding the point at x equals negative 2. So let me rewrite the function. Let's just get those to be precise. So we have x plus 1 over 2x plus 3. That was the original function. If x equals 0, we get y equals 1/3. So the y-intercept, this point right here, is 0, 1/3. If I set this equal to 0, I get x plus 1 is 0. And so the x-intercept is going to be negative 1. So it's over here. And now I'm going to plug in negative 2 just to have another point. So it's negative 2 plus 1 over 2 times negative 2 plus 3. That becomes negative 1, and then negative 4 plus 3 is negative 1. Oh, that's going to give me positive 1. So there's 3 points. That should be enough, and this is our graph.